Welcome to BKW Physics. I'm Mr. McConley, and we're starting the topic of electrostatics. Electrostatics is defined as the study of electrical charge. And most of you, when you think of, you see the word static, you're thinking of static cling. Like you take some clothes out of the dryer and they go crackle, crackle, or you move quickly under the sheets in your bed and you see sparks. And we'll get there. That's all in this topic. There's some great stuff. But we're going to start with some basic. Where does charge actually come from? When you think of charge, where is the smallest, where is charge?
Electrons and atoms.
Okay, so you're thinking of atoms. And in atoms, in the nucleus, you got positives. And around the outside of the nucleus, you have negatives. And we call those protons and electrons. Right, so that's where the basis. And we'll learn later in the year, actually, that charge actually can be broken down into even smaller pieces. Okay, but for now, that's a great start. So, if you have a deficiency of electrons, like you don't have quite enough, is that object positively charged or negatively charged?
Positive.
Yeah, if you're missing electrons, that's positive. And if you have an excess of electrons, that's a negative charge. Okay? I'm trying to hit some of the basics. Another basic is attraction. If you have two items that are of the same charge, a negative thing and a negative thing, are they attracted or repelled? Okay, so attraction goes like this. If you have like charge, you are repelled. Or the things with like charge repel each other. If you have opposite charge, you're attracted. Okay? So that's just a quick review of some basic items of electrostatics. From this point, I want to get into some topics, ways that you can charge things. So one way that you can charge things is by conduction. And most generally, if you're talking about conduction, the two items that are charging one, or one item that's charging the other, however you want to think of it, they're going to touch each other. That's the key. In conduction, there has to be a contact, a touch. And the other one is induction. And in this case, the two items that are charging one another, they don't touch. So there's no touch, but there's going to have to be a grounding. We'll talk about what that means. Okay, there's no touch, but there's going to have to be a grounding if you're talking about induction. So, moving real quickly along here, I want to spin your attention into the room here, and we're actually going to do a few demonstrations to show okay. So that looks pretty good there. I'm going to start with this item right here, which is actually called an electroscope. Make sure that you can see that. Can you see the bottom of that?
Yes.
Okay. So we got an electroscope. An electroscope, basically, if I pull up the glass here so you can see clearer, it's just a metal rod that travels down, and then there's two dangly pieces of, I don't know, they look like tin foil, but they're not. They're actually gold foil. Okay? So they're actually thin sheets of gold that look like aluminum foil or tin foil. And they're hanging there, and the reason we use those is because they're great at moving electrons or moving charge. You know, they conduct well. So what I'm going to do here is I'm going to take a piece of fur and a rubber wand, they call it, and I'm going to try to charge this up statically. Now it's not a great day out. I know you can't see that in the video, but we're a little bit cloudy. It's not totally clear, so static electricity is not awesome today. But I'm hearing some crackling, so we are getting a little bit of static electrical charge. And when I touch this, that's conduction. The people that are on the ends, and if you can't see over here, you should move so you can. The two pieces of gold foil separate from each other. Okay? And then I'm going to do what I talked about with grounding. Grounding is when you give the electrons a way to leave the object that's charged and go to the ground. So my body is fairly large in comparison to this tiny little thing, and I am standing on the ground. So basically when I touch this, my body will absorb all the excess electrons. I don't feel it because it's not enough to really affect me. But I touch that, the electrons drain into me. Now that's grounded, and it's back to neutral. So now let's do the demo again, and I'll talk through it a little bit more. So right now, it's neutral, meaning we got an equal positive and negative ratio. When I charge this, I am scraping electrons off of this fur. Physically, scraping electrons off of this fur. That's the process of what I'm doing right now. And I'm collecting them on this wand, and this wand is plastic, so basically it's a non-conductor, so the electrons don't travel down the plastic and go into my hand, because remember, I can ground things, but they don't because this is a non-conductor, so they all just pile up on the wand. So you can think of all the electrons piling up because they can't seem to go anywhere because this is a non-conductor. So now I have a pile of electrons, and when I touch it, even when I get it close, you see how they're starting to wiggle? But when I touch it, where do the electrons go? Well, the electrons want to get as far away from these other, because they don't like to be near each other. Remember, if you have like charges, they repel one another. So you got all these electrons. They hate being next to each other. And now I give them a chance to move a little bit farther away. So where do they go? They go right to the bottom of the gold foil, because that's as far away from this group of electrons that they can get. So some of them go down there, and now the electrons can spread out a little bit. But when you have all those electrons on the two pieces of gold foil next to each other, what do the gold foil pieces do? They push apart from one another. Can you envision that? Okay. So that's one demonstration of conduction. Now here's a, well, let me start with this one. If I have these two things, I ground them, they're both neutral. Now, I'm not even going to actually do this, but say I charge this up and I make this really negative, okay? And then I hold it close. I hold it close. So if there are any negatives on this sphere right here, which side are they going to go to? Well, they're going to travel to the opposite side because they're trying to get far away from this negative. Can you envision that? Now if I keep it close, so imagine the negatives are all pushed over here to this side, I bring it over and I touch it to that one, where the negative's going to go now? Kaylee, can you point? So the camera can see?
Okay.
So all the negatives are going to move as far away as possible, or they're going to go over here. Okay? Now if I keep the wand there, so all the negatives are pushed to the right side of the screen as you're looking at it, or the right sphere, and I pull it apart, what have I just done? I have pushed all the negatives onto this sphere, and basically this sphere has a deficiency or a lack of negatives because I pushed them over and I never touched. Watch again, we ground it. We have a negative charge. We're pushing the electrons to this side. Now we touch them, the electrons push right over to this side, and when I separate them, I got negatives on this side and I got lack of negatives on this side. So I have separated charge. Keeping that idea in mind, check out this demo. This is kind of cool. This is a piece of styrofoam actually called pith. Like they made pith helmets in, I think it was World War I. So it's a material that is, first of all, it doesn't conduct electricity well, and it absorbs shock pretty well. That's why they put it in helmets. That's totally besides the point. Social studies there. But so we, first of all, I need a grounder. Can you be my grounder? Because I'm getting all staticky. So when I ask you to, like right now, can you just touch that? Actually, with one finger would be fine. Just touch the pith ball. All right, we've grounded it out. We're convinced it's grounded, but stay close because I'm going to need you again. I charge up the wand here, and you can see that it's kind of pulling. It's pulling. I'm not going to let it touch, but it's pulling. Now, if I allow it to pull a little bit, and you come on over again, and just touch it with your finger. Now I'll pull away. Whoa, that happened quick. Let's do it again. Ground it out. That happened too fast for people to see. Okay, when you come over, just go like this and remove your finger. Just touch it real quick, okay? So, it's grounded. We bring it close. It's got some attraction. Go ahead and ground it. Now, watch what it does. Now I can chase it around. It doesn't even want to be near me. Okay? What have we just done? Let's play that out in slow motion. So, he grounds it. Go ahead and ground it. Ground it. I have a charged wand here. It kind of wants to be attracted. So that means, you know, we got negative here, and some, you know, the negatives, it's kind of attractive, but not really. It was kind of weak. Then when you ground it, what are you allowing the negatives to do that are in the pith ball? So you bring your finger on over. Go ahead and act like you're grounding it. So now where do the negatives all go that were in the pith ball? Into you. And once they go into you, this thing immediately goes zoom, and it goes over and it touches this. Okay, did you see how quickly it came over and got attracted to it? But then what happened immediately after that? It went, ah! And then it wanted to get away from me. Because after it touched it, what did it pick up? Negatives. A lot of negatives. So now it's got a lot of negatives, this has got a lot of negatives, and they hate each other, and I can chase it around. But that all happened in a quick interaction there, and I moved charge around without even touching it, just by using grounding. This is induction. So for today, we've seen conduction and induction. Physics.